This is CPE 233 Experiment 1M, and this introduction, kind of a description of the experiment. And so let's go through this thing. So what it's going to do is, on a button press, it's going to read data from two different ROMs, and it's going to find the greatest common divisor of those two pieces of data. And if that greatest common divisor is odd, it's going to store that value in RAM at the same address it got the data from the ROMs. Okay, if it's an even number, it's simply not going to store anything. So the RAM it fires up with 0 in all the locations, so it's just going to remain 0. So you're going to repeat that for all 16 ROM addresses, and then you're going to step through what you found in the RAM and look for the value with the greatest magnitude, and once you find that, you're going to display that. So this experiment essentially has 4 parts to it. One is the starting state, where it's waiting for a button press, and in that state it's actually displaying the greatest common, whatever is displaying the greatest value it found from the RAM, which you haven't done anything, so that's going to be 0. Next thing you're going to do, you're going to step through the ROMs, find all the greatest common divisors, store them if they are odd, and that's it. And then after that, you're going to step through the RAM and find the value with the largest magnitude, and then you're going to display that. And by displaying that, that means you're going to go back to step 1. So the constraints on this are that only use standard digital modules. Don't make any magic circuits in here. All of these modules are provided for you in a complete form, except for the FSM module, which we'll talk about in a second here. And what you're going to do is use the instantiation template in those modules. You're not, essentially, this is a cut and paste exercise. And what you're going to do is override the parameters when you need to. So I don't want you changing the modules, and no need, and I've certainly cut and paste all the modules except the FSM module has a instantiation template in the header. Cut and paste that thing. Okay, don't use mathematical operators in this thing except in a ripple caryadar or counters if you need them. The important part is the FSM. This circuit is driven and controlled by a state machine, and there is a template on Canvas of a state machine. It does not have an instantiation template in there because you're going to change it a lot. We will talk more about this template later. For this design, you don't need more than 8 states in here. I think the ideal design is 5 states, but you can do it however you want. The FSM should be 100% independent of the ROM and RAM sizes. The state variable should be the only memory in your FSM. And let's see, don't put data of any type into your FSM because it makes your FSM non-generic. The only thing you're going to put in there only thing you're going to input your FSM is status data. And so the experiment has other details in it, particularly on the constraints side. So once again, use only provided modules. You don't need to write anything. You don't even need to change the modules. You'll need to change the FSM template, but anything else, don't change it. If you do change it, I'll kick it back and tell you to fix it. Okay, so the bunch of standard modules out there on Canvas provided for you, including a generic RAM, and the 2 ROM files are provided for you also. There's an FSM template. There's no instantiation template in there because it's going to change drastically. You're expected to change that one. There's also a universal 7-segment display module. Hopefully you use that in 133. So the typical design approach is, I will say top down. Understand the problem, select the modules you're going to need, connect them up, and when you connect them, what you're doing is connecting data and controlling the status lines. And at that point, it's ready to, create an FSM. So what you're going to do here is start with a state diagram. You have a state diagram, translate that state diagram to actually Verilog code and put it in your project. So, the idea here, understand the problem. Keep it simple. Don't try to be clever. I would take it in stages. The process is iterative design, meaning that you do something, you're probably going to have to go back and do it again, fix it, or go back and add something along those lines. So once you got it all designed on paper, model it with Verilog, test the design on your board, and if it's not working, well, certainly you're going to have to possibly use the simulator on this. Most importantly, I'm here to help. Ask questions, send me diagrams, do anything. Show me pictures, and I'll give you my comments right away, just to help you get this thing done. This is the top level diagram for the circuit, and you can see it's just the inputs is the button, and the outputs are just stuff that is going to make it look good on the board. Anodes and segments are for the 7-segment display. The LEDs are just LEDs to help you figure out what's going on the board. This is the greatest common divisor module. As you can see, it has two inputs here, which are the data inputs, and it has a control signal, and it has a status signal, and this is data. And so what you're going to do is give it some data, and then you're going to turn the go signal on. And you hit it with a pulse, and once you turn that go signal on, there's a done signal in there, and the done signal is going to go off. Okay, at that point, any valid data that you have is going to disappear, and the GCD module is going to start cranking out. It's going to start looking for the GCD. Once it finds the GCD, it's going to turn the done signal back on. So that done signal is a status signal. Go signal is a control signal. Okay, very important. Okay, the different ways to do this. I know this is a lot to hit you at first here, but you don't have to do the whole thing at once. A really good start for this circuit would be to plop your ROMs down, your counters, and your 7-segment display, and just simply put it in the mode that displays two pieces of data and show that you can step through the entire ROMs displaying the data. Okay, once you've got that done, you're really about 75% done. This experiment's not overly complicated, but the display issues get kind of complicated, and so there's different modes. In different modes, you're displaying different stuff. It's all in the experiment. You'll see it in the demo as well. So anyway, start small. Take baby steps. You'll get there. You don't have to do it all at once. In fact, if you try to do it all at once, sometimes it gets really complicated. Okay, so this is due essentially 2 weeks from the day it's assigned, so it's essentially 2 weeks from Monday. Certainly, you want to start early so you can ask questions. Certainly send stuff by me. Show me pictures, ask questions, do whatever you need to do. So it's not a simple experiment, but it will prepare you. It'll be for the remainder of the course, plus it'll be a great review of CPE 133, particularly if your instructor didn't do much with state machines.